So you want to learn Arduino. You probably seen them all over YouTube and want to get started building cool. Arduino is pretty easy and actually. Here's everything you need to know. So what is it, how does it work, and how do I start building projects with them? Firstly, this is an Arduino.
It's a circuit board
which acts like the brains of an electronics project. It has a bunch of pins that you can connect components to, such as lights, motors, and buzzers. And by writing code, you can program it to control these components. This Arduino is made by an Italian company called Arduino. Arduino makes Arduinos, and they make many kinds of Arduinos. This is the Arduino IDE, the standard one. This is the Arduino Nano, great if you have size limits. And this is the Arduino Mega. This one's great if you have no size limits and maybe want more pins. These are the most popular classic Arduinos. Arduino open sources the designs of all the Arduino boards. This means that everyone has access to the designs for free, and so many other companies have cloned the schematic and layout of the Arduino board. Clones are made of exactly the same parts as the original, with the same form factor, but normally are a little cheaper and have slight differences in appearance and functionality. We mentioned earlier that Arduinos are like the brains of an electronics project. At the heart of the Arduino is something called a microcontroller. Think of it as a mini computer that can handle specific tasks. The one on the O is called the Amiga 3280P. It's got an 8-bit processor, memory to store the program, and a clock speed of a whopping 16 MHz. But anyway, this microcontroller is made by a company called Atmel. It costs around $3 on its own. But to actually use we need the rest of the Arduino board. Let's quickly run through the main parts. Here's the USB port. You use this Type B to a cable to plug it in. This gives it power and also lets you upload code. This part here is the USB to serial converter, which is like the translator that interprets the USB signal to serial. Is just a method of communication that the Arduino uses. This polyfuse stops it from drawing too much current. This voltage regulator gives the Arduino a 5 volts, and this one does a clean 3.3 volts. If you didn't want to power the Arduino with the USB cable, you can use the DC barrel jack. The onboard LED is useful for basic programs and debugging, and there's another for TX and RX. So when data is transmitted, it flashes, and when it's received, it also flashes. And this button will reset the Arduino when you press it. The pins in this row are called digital I/O pins. I/O means input-output. These pins have 3 modes. You can program them to be high, which will output 5 volts, and a component connected to this pin will turn on. You can set them to low, which will output 0 volts, and a component connected to that pin will turn off. The third mode is setting them as inputs to read signals coming from the pin. This is useful if you have components like a button, because you can read the voltage level at the pin to know if the button has been pressed or not. Pins that have a tilde sign next to them are capable of generating pulse width modulated signals. Basically, these pins have the capability of turning on and off really fast, which can be used for finer control over things like the brightness of lights and the speed of motors. This light looks like it's on 100% of the time. But really, I'm just turning it on and off so fast. I see it as 50% power. The pins in this row are called power pins. They're used to power components. The 5 volt and 3.3 volt pins provide a 5 volts and 3.3 volts respectively. This is the ground pin to ground all of your components. If you needed another way to power the Arduino, you can use the VN pin and hook up 7 to 12 volts, and it'll lower it to 5 volts. The pins in this row are called analog input pins. They can measure continuous voltages, so not just on, but a wide range, and convert them into digital values. Since the microcontroller works with ones and zeros, these pins are connected to the analog to digital converter, also known as the ADC. The ADC takes the continuous voltage from the pin and converts it into a digital number that the microcontroller can process. The ADC has a 10-bit resolution. What this means is that it has 1024 different values, and we can map 0 to 5 volts to these values. A 5-volt signal would be read as 1023. A 2.5-volt signal would be represented as 512. And a 0-volt signal would be represented as 0. If you want more functionality to the Arduino, you can attach a shield to it. Shields are circuit boards that mount on top of the Arduino. For example, this is a data logger shield, which allows you to record a bunch of data by connecting an SD card. This one's a thinker shield, which connects lights, button potentiometers, buzzers, and even a light-dependent resistor. Also, side note, the whole point of Arduino is to use it with components. So if you're getting started, you should get a kit with a variety of components. Let's take a look at the software side of Arduino. Now the company Arduino have also made software that allows you to write and program the Arduino really easily. The software is called the Arduino IDE, and the programming language that it uses is a modified version of C++. To get this software, search for Arduino IDE in a web browser and click the first link. Download the Arduino IDE 2. From the options available, select the appropriate version for your computer. Follow the basic installation stuff, and that's pretty much it. To connect your board to the computer, use the cable, and in the drop-down menu, select the option that says Arduino USB serial. Click on this option to connect to the Arduino. A program that runs on an Arduino is called a sketch. A sketch needs two functions to work. These two functions are called the setup and the loop. In setup, any code that you put between these curly brackets will run once in loop. Any code that you put in between these curly brackets will run again and again. So let's say I have an imaginary code 1, code 2, and code 3 in the setup. I also have code 4, code 5, and code 6 in the loop. The Arduino will run this setup. It will run code 1, code 2, and code 3. Then the Arduino will run the loop again and again. So it will run code for code 5, code 6, code 4, code 5, code 6, 4, 5, 6, 4, 5, 6, and it will keep running this loop until it loses power. You might come across these grayed out pieces of code. These are comments, and they have no effect on the code. It's kind of like annotation and just gives a reader more information. Let's write a simple program to blink the built-in LED on the Arduino. On and off this LED is connected to digital pin 13. To blink this light, we need to set the pin as an output. This means it's outputting a digital signal of high or low, so we write pin mode 13 output. Since we only need to run this line of code once, we write it in the setup function. Then we need to write the main blinking sequence in the loop function. To do this, we can use the digital write function in loop to turn pin 13 on and off. We turn it on by using digital write 13 high. Then we wait for 1 second using delay 1000. Then we turn it off. Then we wait again. This sequence will blink the light on and off. To upload the code to the Arduino, click this arrow button up here and wait until the code says finished uploading. Now the Arduino will blink on and off. This is the most basic project. Things get way more interesting when you start connecting components to the Arduino. The quickest way to connect components is by using breadboards and jumper wires. These to give you the base to build larger circuits and then connect it to the Arduino here. I connected the Arduino to an LED and a resistor. Then I connected it to pin 13. So now, instead of only blinking a small inbuilt LED, it also blinks this external LED. The stuff you can build doesn't just stop at LEDs. Here's a reaction speed game. It uses LEDs, a buzzer, and 2 buttons. The game will start by counting down from 3, each time flashing a different light with a short buzz. This sequence is controlled by a series of digital writes and delays. Once it's finished counting down, both white LEDs turn on, and whoever presses their button first will win the game. When the button is pressed, the LED on the other side will turn off, and a buzzer will ring. We use control structures to make the Arduino wait indefinitely until a button is pressed. Here's another example of an Arduino project. This is a sonar scanner. It uses a servo motor to spin an ultrasonic sensor around. Then the distance of the ultrasonic sensor is repeatedly checked. When the distance is far away, the LED will be green. When the distance is in close proximity, the LED will be yellow, and then the buzzer will make a low sound. When the distance is in very close proximity, the LED will be red and the buzzer will make a high sound. Alright, so what if you could build these projects in a weekend? That'd be sick. Wouldn't it? No prior knowledge needed. Number 20-hour courses. No scouring across YouTube for fundamentals. Everything you need all in one place. You can actually understand Arduino. Wait, I just dropped the starter course for Arduino. Video walkthroughs, components, diagrams, theory troubleshooting, and a community of people blazing the same path as you. If you want a quick and practical course to get started with Arduino, check out the Robotics Academy links in the description. But anyways, that's Arduino explained in a nutshell. See you soon.